I recently came across this really cool concept that oxytocin and ADH are really similar, and so that oxytocin can act as a antidiuretic and ADH can stimulate smooth muscle contractions. And so I just wanted to go over some of their similarities and each hormone and what it does, and then their chemistry and the clinical importance of what they do. So first, their similarities, they're both made in the hypothalamus, and ADH is made by the supraoptic nuclei, and oxytocin is made by the paraventricular nuclei. And then these hormones, so they're made there, and then they can be released through the axon tracts of the nucleus, or of the neurons, and down, and they will be released into the posterior pituitary. And that's where they're released into the blood. Now for just what ADH does. So ADH is antidiuretic hormone. This would be a diuretic is it makes you pee, and so an antidiuretic would mean you don't pee. So it's gonna help you hold on to water. So it can also be called vasopressin. It's called vasopressin because since it's helping you retain water, it's going to increase your blood pressure through increasing your blood volume. So ADH is going to act on the kidneys. It's going to increase water reabsorption in the collecting ducts. If you know what the kidneys look like, you have your glomerulus, and then you're going to have the proximal convoluted tubule, the nephron loop, the distal convoluted tubule, and then you're going to have this collecting duct. And how it acts is it will usually, the collecting duct here is impermeable to water, but ADH will act on the collecting duct and it'll open these little sections of it called aquaporins, and then this way water can leave through here. So that is how ADH works, and it acts on those V2 receptors here in the collecting duct. It's released from the hypothalamus. It's responsible for the thirst reflex, or it is released because of the thirst reflex in the hypothalamus. What happens is you have these osmoreceptors in the hypothalamus, and as cells, right? If you have a cell and it's full of water, but then that water leaves, your cell kind of shrinks, right? And so then those osmoreceptors shrink, sense the shrinking of those cells in the hypothalamus, or like or the expansion of them, right? If I've had a lot of water, then that means I have a lot of water in my cells. That's one of the problems with water toxicity, is that your cells can become too large and they can burst. And so, and that can include neurons and things, so that'd be really bad. So the osmoreceptors sense that your cells are shrinking or they're getting super big and they're going to burst. And so then that can trigger the thirst reflex, releasing ADH from the hypothalamus to the posterior pituitary. Posterior pituitary puts it into the blood, and then it acts on the collecting duct, V2 receptors, gets those aquaporins open so water can be reabsorbed. So this would mean that it would also really concentrate your urine while we're trying to hold on to water. Next is oxytocin. So oxytocin's brand name is Pictocin. So that might be if you know someone who's ever, their labor's ever been induced, they might have gotten a Pictocin drip. So this is going to act on the uterus and breast. It is triggered by the Ferguson reflex, which which occurs as the cervix distends, and then that will increase oxytocin. It'll increase your oxytocin release. Oxytocin is going to cause smooth muscle contractions in the uterus. So when giving birth, you will start to release oxytocin from that from the distension of the cervix, right? And so then as labor progresses, you get more contractions, and oxytocin is a positive feedback loop, so it means that you'll continue to release more oxytocin as you get farther in labor and as your uterus contracts more until birth. Then oxytocin also acts on the myoepithelial cells in the breast, which is why oxytocin also helps with milk letdown. So there's a hormone prolactin, and prolactin is you make breast milk, and oxytocin is what helps you to release that breast milk. And so it's the same kind of thing. Muscle contraction, you're releasing milk, muscle contractions in the uterus. But these oxytocin and ADH are really similar. So here is what they look like. And we can go through and kind of see really the differences are here. This is going to be a leucine group. And then up here we have arginine. And then the other big difference is here we have a phenyl. Sorry guys, I can't write and talk at the same time. A phenylalanine group, and then here you have a isoleucine group. But other than that, every group, every amino acid group that's on here is the same. And so you can see how these hormones are chemically very similar. And so then they could even, they're so similar that they can bind to some of the same receptors. And so that is where I want to get into the clinical importance of this. Because they're so similar, they can act as one another. So they're both peptide hormones, and they're similar enough to bind to the same receptors. And so that oxytocin can have a antidiuretic effect. And so while I was researching this, I found a case study of a woman who was in labor, and she had drank, I think her husband said 5 bottles of of water, and it didn't have many electrolytes in it. And so she then suffered from water toxicity during her labor. So she had seizures because she was retaining so much water, because oxytocin was having this antidiuretic effect. So she wasn't peeing. So she increased her water intake, right? And then we have an increase in oxytocin. So then she didn't pee everything out. And so then that's how she got this water toxicity. Her baby were fine, but it was just an interesting case study that that oxytocin can have this effect. And then also ADH can bind to smooth muscles in the uterus. So let's say you're pregnant and you're not drinking enough water, and so then you're dehydrated. Then ADH can actually, in theory, it could induce some uterine contractions. Because also, if we think about it, another way ADH works is ADH can act on another way that it can bring up your blood pressure is that will cause the smooth muscles in your blood vessels to vasoconstrict. And so this is interesting, because then if it can work on the smooth muscles in your blood vessels, it can also work on the smooth muscle in your uterus. And so just some important things to keep note of, that during labor, yeah, you got to be careful how much water you are drinking, making sure you're still peeing. And there are medications they can give you to counteract these hormones, just to make sure that you have a safe labor, and that ADH could actually, in a potent enough concentration, it could induce labor in someone who's pregnant if they were dehydrated because they're releasing all this ADH. So that's just something I found really cool. I hope to make more videos like this. But thank you for listening. I hope you found this interesting. And let me know if you have any topics that you think are interesting that you would like to see researched.